Hi, and welcome to this new video in the series on Bluetooth Low Energy technology. My name is Mohammed Afani, and in today's video we'll be covering one of the most popular applications of Bluetooth Low Energy, Bluetooth beacons. Some of the topics we'll address in this video include defining what a beacon is, then we'll look at how beacons work, and then we'll get into some of the beacon standards out there, including Apple's iBeacon and Google's Eddystone. And finally, we'll look at some of the applications of beacons in the marketplace. Let's first start by defining what beacons are. Beacons are Bluetooth Low Energy devices that broadcast advertising packets. They usually stay in the advertising mode and do not accept connections from other Bluetooth Low Energy devices. Their advertising nature allows multiple other devices to discover them at any point in time, and they're used primarily for proximity awareness and location tracking applications. The concept of beacons originates from the simple lighthouse application in the real world. Lighthouses send out light signals in order for ships to discover it and be able to tell where their location is. In a similar fashion, a Bluetooth beacon sends out advertising packets for other devices to discover it. A common misconception and myth with beacons is that they're able to track users and mobile devices. Beacons cannot track devices in general because all they do is send out advertising packets that allow the other devices to discover it. Now, the data sent in the advertising packet varies based on the standard being used. In general, however, a unique identifier is included along with namespace identifiers. Think of a namespace identifier as a number that indicates a location and an area within a specific location. The scanner device is usually a mobile device running a specific mobile app. The advertising data from the beacon is passed to the mobile app, allowing it to detect the namespace identifiers to determine the location of the beacon, such as a city, building, etc., and the assigned area within the location, for example, the first floor versus second floor or aisle 3 versus aisle 2 in a supermarket. In addition to that, the proximity of the beacons are reported to the mobile apps based on the RSSI of the signals received by those beacons. Some of the most popular beacon standards out there include Apple's iBeacon standard, as well as Google's Eddystone standard. Many of the beacon hardware vendors support multiple or all of these standards to give their customers the flexibility to implement those standards. Now, some of those beacons can even implement different multiple standards to be running simultaneously by alternating the transmission of the different packet types. Now let's talk about each of these standards in a bit more detail. First, let's look at Apple's iBeacon standard. iBeacon was introduced in iOS version 7.0 in 2013. It was the first mainstream standard for Bluetooth beacons. The standard defines the packet structure of the advertising packets that are being sent by the beacons. This includes the UUID, which occupies 16 bytes, as well as a major number occupying 2 bytes, and a minor number occupying 2 bytes as well. And finally, we have the transmission power occupying 1 byte in the packet. The UUID is a specific value assigned to an app or deployment use case. The major number defines the region within that UUID, and the minor number defines a subregion within the major region. For example, for a specific chain of retail stores, the UUID would be common across all these stores. The major, for example, would define a store at a specific location. So for example, a store at location A would have a different major than a store at location B, and so on. And the minor could define the aisle or the floor, for example, within each of these locations. The iBeacon standard also defines the iOS APIs that allow iOS developers to develop applications that interact with iBeacon compatible devices. It requires signing a license agreement with Apple to use the name and claim compatibility with the standard. However, developers can still develop and utilize beacons that transmit iBeacon packets without signing the licensing agreement. In this case, they would not be able to state that their devices are iBeacon compatible, but they can still develop the apps that leverage iBeacon functionality. The biggest advantage to using iBeacon is the rich integration within iOS. Some advantages include privacy controls, alerts for apps that are running in the background, launching an app that has been shut down, and then regioning and proximity reporting back to the app using the ranging API. and finally displaying specific passes within the Wallet app in iOS based on proximity to specific beacons. It's important to note that iBeacon works with both Android and iOS, but native support is exclusive to iOS. As we mentioned previously, iOS provides APIs for determining the estimated proximity to a beacon. The proximity process is referred to as ranging, and it provides 4 different proximity states. The first state is the immediate state. It provides a high level of confidence that the beacon is physically close to the mobile device. The near state provides a proximity of around 1 to 3 meters with clear line of sight, and the far state indicates that the beacon is detected but confidence in accuracy of near or immediate is low, and it could be due to obstacles in between the mobile device and the beacon. The last state is the unknown state, and it simply indicates that proximity cannot be determined or that the ranging process has just begun, eventually leading to a more accurate proximity decision. The other popular beacon standard is the Google Eddystone standard. This was introduced in 2015 by Google as a competitor to Apple's iBeacon standard. It added some significant enhancements compared to iBeacon standard, including beacon management and configuration, the ability to directly send out a URL to a scanner, privacy and security measures, as well as the lack of need for a specific mobile app, and instead is integrated into the Chrome browser on the user's device. The packet structure for a Google Eddystone packet depends on the type of that packet. In Eddystone, there are 4 types, versus only one in iBeacon. The first is the Eddystone UID, a unique static ID with 10-byte namespace component and a 6-byte instance component. The second one is the Eddystone URL, which is a compressed URL that, once parsed and decompressed, is directly usable by the client. The third type of packet is the Eddystone TLM packet. This provides status data of the beacon and is useful for fleet management and maintenance. The last type is the Eddystone EID packet. This is a time-varying data that can be resolved only by authorized clients, allowing for more privacy and security measures. Some of the most popular applications for beacons in the market include retail marketing, by presenting coupons, rewards, and savings to customers when they approach a beacon located within a store or an aisle. Another application is in events, ranging from small meetups to large events such as sporting events and concerts. This use case includes real-time updates to attendees as well as engagement between the attendees. The third type of application is for asset tracking, for example within a building. The fourth application is for indoor location services and indoor navigation for users navigating inside a building where GPS does not work very well. And the last kind of application is in tourism, such as in museums and in guided tours. To learn more about Ellysys, provider of the world's most advanced Bluetooth analyzers, visit ellysys.com. Have a need for training or design services? Then contact our training partner, NovelBits, at novelbits.io. I hope you've enjoyed watching this video and learned a little bit more about BLE. Thank you for watching, and I'll see you in the next one.